These are the internals of a Sun distributor machine, and if you're watching this video, you likely have one that doesn't work. And I'm going to go through some of the steps to diagnose what could be the problem. So as you can see, the neon tube is flashing right here. I have my dwell calibrator that does TAC. That's providing a 5 Hertz pulse, so this is triggering, and if we look over here on this meter, we have minus 578 volts. That's on this red wire, and I can't tell you how many times I've been shocked by these, mostly because a lot of these machines, they did grounding through the case, and to work on the power supply on some machines, I would drop down the power supply and I'd have some alligator clip or something connecting the chassis to the frame of the machine, and if that fell off or something, you could get a really bad shock. So I developed an LED circuit to replace this because I just got tired of getting shocked, and well, that's what I do. But, you know, these machines can be fixed up with the existing electronics. Now I'm going to turn off the power here. Wait, before I do that, this would be the equivalent of the clamp going to points. And so if we go to a little screw, this is a ground screw. If we're lucky, once in a while we'll get it to flash. The points on the machine do need a capacitor for this to work well, or, you know, have a calibrator. And many of the machines will have a capacitor hanging on it for some of the older distributors that had external capacitors, and maybe your distributor doesn't have one, so there was one there to make the thing clip. But like I show you, this is a lot of times won't flash just by hitting it. So you really need to have a capacitor. That will not be a good test if you just, you know, try and hit it. So I'm going to turn this off. Some of these machines have an internal resistor. This one does. It's a 470K resistor that drains down the capacitors. As you can see, it takes quite a while for the voltage to drop down. So always check the voltage first. If you're going to make any readings on the terminals, you want to short those out first before you do any ohmmeter readings, because you can destroy your meter. So we're down to 5 volts. Safe enough. First off, these are very delicate. What you have is 2 brushes. This is where the high tension comes in, and both of these wires just come over and wrap around this tube. This tube's pretty weak, but it was even worse. These tubes are electrostatic. They have voltage on them, so they're going to attract dust. And these get really dirty. The lenses get dirty. You have to be very careful. But there's 2 screws. Both of these go to the frame. So this one and this one, I just put a screw in here so I could do this capacitor and run a ground wire. Both of these go to this coil that goes around there. There's nothing magical. It's just to create an electrostatic charge which will trigger the tube. If you want, you can put some aluminum foil on the back of this if you have kind of a weak tube to focus a little more of the light. I'm sure 3M makes a nice reflective material that you may have access to that works much better than aluminum foil. And you can put it on here. You don't have to worry about shorting any of this out, or unless you're actually short it out to the case when it's finally installed. But removing these two screws, and this is a lug that you can remove here. You can take this out and put it underneath your kitchen sink with a toothbrush, some detergent. I like to use Windex. Just ammonia seems to work very well with a lot of things. And you can clean this all and get the dirt off it. Make sure that these don't fall off. These springs are attached to these, but you could lose them pretty easily. This goes up to the cover, which has a circular ring, and that goes to the power supply. And this is the high voltage output from, on this one, the ignition coil looks like this. Looks like kind of a potted capacitor, but the ignition coil is in here. There's a bunch of variances of them, but clean this tube and also the lens because they build up a lot, and it can cut down a lot on your light. Now this capacitor is normally mounted about over here on the rotator. This capacitor has to be in place, or at least has to be good, because if you don't have this capacitor in here and you trigger this tube, the tube will turn on and it'll stay on, and after a short while you will definitely burn it out. So make sure you have your hands on the plug so you can unplug the AC or turn it off somehow. If you see this tube turn on and stay on, you'll have maybe an open capacitor here. So let's look at some of the electronics here. This, as I said, this is the ignition coil. Wires from this just bypass over to this other connector for the tach, if you should have the internal tach sensor that's on the disc. These two capacitors, there may be just one in there. These are the main power supply capacitors. You have an inductor and you have a resistor across that. It's a very simple circuit. You got the power transformer. So let's just look at this schematic here. So here's the coil. The tube, one part of it's grounded, the other part goes to the 500 volts. And this capacitor, it won't necessarily be orange, could be a paper capacitor, could be anything. This is up in the head. Now, in the center contact of the rotating disc, there's a carbon brush that hits the center contact, and you'll have a phenolic board, and it'll have 3 fingers here. This bar goes in and out and connects either none, 1, or 2, or 3 of these, depending upon the speed. In a rebuild, it'll have 3 little capacitors like these. These are 0.22 UF. And again, here's the coil, and there's a resistor across that. So with your ohm meter, remember, power should be off, and you should have shorted out this high voltage to make sure that there's no voltage still left on the capacitors. Like I said, the later ones have a 470K resistor that goes to ground that will drain it off over time. It takes at least 5 minutes to get the charge really down. You can't make your ohm meter measurements without the voltage being set to 0. But the coil resistance is about 400 ohms. They have a 2500 ohm resistor across it. Some of these coils get very old, and it's just metal connectors kind of snapped onto some cardboard, wrapped around paper, and if you put any force on this, you can easily break the wire, so be very careful with that. But across that coil, it should measure about 400 ohms. If it's way above that, then you know you've damaged the coil and it won't work right. But basically, the first test you want to do is check the resistance. So I've had this thing off for a while. I'll do the resistance here. See, it's about 3.9K. That's because we have diodes in here, and they're showing some conduction. With a tube, you wouldn't see that. So I reverse this, and you can see that it'll jump eventually to about a 0.5 megohm, which is the resistor that's in here. Some of these don't have it, and it could be very high, but you want at least a value over 500K between the high voltage and ground. And the transformer, on one side, the AC, it's 8 ohms. On the power section, it's 360 ohms to the center tap. So across the two would be 720, something like that. And again, if it has the internal power supply, some of these are totally battery operated. This one provides about 8.4 volts. When you apply a load to it, in other words, your points are closed, the voltage will drop down to about 4 or 5 volts. So you want to have some voltage that appears on your the lead that comes out to go to the points. But that's the main thing. If you're going to power this up, you're going to want to see about between 500 and 600 volts right at where that tube is, right on these connections. And the positive will be this side, and the negative will be the screw that comes over here. And if you have that voltage and you can't get the tube to flash, it's a good chance the tube is bad. Now, I've seen these on eBay, and they wanted $600 for a replacement tube, and and the listing says, you're buying it new in the box, we're not testing it, no guarantees. So $600 for something that may not even work is a lot of money. And Paramount sells these capacitor kits. This is a kit that was, I think I was told they paid $200 for this kit. So they give you 2 capacitors, they give you a resistor, and 2 diodes to replace the tube. This capacitor was provided. These 3 capacitors are on the phenolic board that's behind the center contact of the rotating disc. Now, sometimes they're individual capacitors. A lot of times it's just a big square block with 4 wires coming out of it. If you have a low resistance, it's going to drop your voltage, and also it'll, short out. You won't have enough voltage to flash your tube. So that's about it. If you don't have check for a short first on these 2 pins. Shorter capacitors will be something in the low resistance range. And then if it's not shorted, power it up. Look for between 500 and 600 volts on these terminals. Be very careful. It's a nasty zap, I'm not going to be an alarmist saying you can kill yourself, but you will remember that shock. And clean this board, because I'll tell you, this is not very bright. This is a weak one. You saw it flash. You know, if you're in a dark room, you could use this, but like I say, this is old technology. It's expensive. You can't get these anymore. It's just easier to go to LEDs. But if you have a good tube, a lot of these machines weren't used that much, and so it's very possible that your capacitors are bad. The kit for Paramount, they tell me it's like $200 for, you know, just a few capacitors and a couple things. You can go out and buy that stuff for less than 20 bucks. And you can try and repair it. And if it doesn't work, then you can think about going to LEDs. The LEDs are nice.